Good afternoon, everyone. It's my pleasure to welcome you all to what promises to be a riveting panel discussion on new techniques and technology in exploration. Woo! So, yeah, let's go. So it's thanks to Axiom Group for giving me the privilege to be here to moderate this today. My name is Sean Hilliker. I'm the president and VP Exploration for Standard Uranium. It's also a junior exploration company operating in Saskatchewan. So know all of these panelists fairly well. Alice, it was nice to meet you yesterday. Looking forward to talking more today. So yeah, that's let's kick things off here. We got some time to kill. So pass it over to the panelists here for their introductions. Alice, Richard, Doug, and Dan. Go ahead, Alice.
Okay, great. Thank you so much, Sean. Can everyone hear me all right? Yes. Yeah, all good. Okay. Well, hi everyone, I'm Alice Deneen. I'm here with Geotech Limited. We're a company that specializes in the manufacture and design of automated core scanning systems. So we actually had our roots founded in the early 90s. I mean, core scanning has been around for a few decades now. And our roots are really mainly in research and academia. So we were really focusing on physical property analysis, things like density, porosity, trying to understand our core samples in more detail. Since then, we've looked to integrate a range of different parameters like geochemistry, so things like XRF elemental chemistry, VNR and SWIR for mineralogy, color data, high-resolution imaging. And what that's basically allowed us to do is branch out from purely research and academic routes into different industries, so into mineral exploration, oil and gas, geotechnical, basically anyone who has core samples, right? So thank you so much for having me here today, and I look forward to discussing further on the panel.
Thanks, Alice. I'm Richard, everyone. Nice to meet you all. So I'm with Fleet Space Technologies. As the name suggests, we are actually a space company. We build and launch and operate 8 dedicated mineral exploration satellites. Why that's interesting is because we utilize those satellites to transfer data in near real time for mineral exploration. So we have an ambient noise tomography, ANT product. We build dedicated sensors to collect that data, and then we build on top of that with other data sources as well, with gravity, and we've now got some AI drill targeting software as well.
Thanks, Richard. Just want to thank the panelists and Sean for putting their time in coming out, and Julie for putting all this together. So those of you who don't know me, I'm Doug Engdahl, a subpar geologist and the CEO of Axiom Exploration Group. And so I think most people know what Axiom is or does, but I'll leave it at that. So I'll have nothing left to talk about if I say that piece. So anyway.
Thanks, Doug. Dan Brisbane. I'm with ISO Energy. We're a junior exploration and development company with projects here in Saskatchewan. That's really our roots, but also in the United States and Australia and a couple elsewhere in Canada. And really the history of ISO was it was initially spun out from NextGen, a few projects in the Eastern Athabasca Basin, 2016. And since then, through deals and staking, added quite an extensive portfolio, over 20 projects in the Eastern Athabasca. And then more recently with our merger, I guess basically a year ago, last December, with Consolidated Uranium, that's added the American and Australian projects to our portfolio. And I'd say we're a user of exploration technology, and so that's why I'm here.
All right, thanks guys. All right, let's dive in. So just again, thanks to Axiom Group for putting this on, hosting us in the Saskatoon Club, kicking off Open House 2024. Just a shout out to a quick plug too for the box scan system that Alice is kind of here representing. They had a good demonstration in the core elaboration facilities at Axiom yesterday, which was pretty cool. So great to learn more, and we'll talk more about that today. But okay, to kick things off, let's kind of start a little bit more granular here. Let's talk about the big picture stuff here. So I'm gonna shoot this one to Doug, just, it's your event and whatnot, but I feel like Axiom is fairly exploration agnostic. You guys have a lot of things going on. You have your hands in a lot of different facets of exploration, agriculture, etc. So how do you see technology reshaping, what we do as far as mineral exploration and the life cycle of mineral exploration throughout the next decade, and how does Axiom play into that?
Thanks, Sean. Yeah, I think but technology is advancing technology is super important in any industry or any field in order to stay ahead of the demand. Doesn't matter if it's grain, uranium, doesn't really matter. The technology advancement and should always be at the forefront of every industry. So Axiom is we're I'd say technology agnostic. As opposed to exploration agnostic. So when we started out Axiom, we saw something I think that was missing in the industry for a turnkey company that you don't have to call 16 different companies, and the exploration company, we focused more on execution as opposed to tendering or procurement. So, if we don't have it in our arsenal, and it's not the best tool we don't have the best tool for the job, we usually know what is, and then we just connect that group. So technology and exploration, it's getting, I could say more difficult. A lot of the near surface, a lot of the low-hanging fruit, you hear that all the time, has kind of been picked over for the most part, and exploration ain't getting any cheaper. So the best way to, I guess, quantify your uncertainty on any project and increase your probability of discovery through technology. But I think there's something that's really missing, and talk about all this different technology is your data room, or your source data, or your foundation of your company. While you keep adding new data, you haven't really even properly looked at what is sitting there. And in your own data room, whether it's unorganized, unvetted, not standardized, and the use of different AI and other technologies is kind of useless to you if you don't have that fundamental, basic, and the most valuable asset an exploration company has. It's not the minerals, it's not the metals, it's your data. So I think that's it's something that's overlooked a lot. So yeah.
Sure. Yeah, I think I would just echo what Doug just said. To me, there's, if you look back through exploration history, there's been step changes in technology. Like you think of the advent of EM surveys after World War II, and then continuing into the 50s through 70s, and a huge number of massive sulfide discoveries made with that technology. Many of the early uranium deposits in the Athabasca once we got onto the graphitic conductor. So there's, hopefully we're going to, as an industry, identify that next step change. But as part of an overall exploration approach, I'd agree. To me, it's a combination of one good point is well-organized data. Like at our heart, we should be geologists and geophysicists, right? And it seems like we get fixated on the technology so much that our real value to our companies is say geologists interpreting or geophysicists interpreting that data. So having the data well organized, accessible, and then easily visualized by your professional staff is one thing, and then combining. So there's developing, we're working with Fleet right now on seismic imaging, but the key to that is not just the really attractive technology itself, but is pairing that with knowledgeable people, whether they be geologists or geophysicists that can interpret those, call them proxies, geophysical proxies, or images of what's that imaging in your ore system, and where does that take you? Where should you be targeting? So yeah, I'm excited about advances in exploration technology, but I'd agree with Doug, making all that data we're collecting easily accessible and getting people to think about the data, not just compiling it away in an appendix in a report or in a database. And then merging the results of the technology with old school knowledge, ore deposit geology, things like that.
Yeah, I would completely agree with everything you've just said there, Doug and Dan. I would just add that I think we're all well aware that as an industry, we're very sort of, I suppose, set in our ways. I mean, I have the conversation with so many people, particularly at conferences, of how hard it is to try and convince industry to actually adopt these new techniques. I mean, we see so many advances, particularly over the last decade, of all of these new technologies that are now available at our fingertips. And you see the tier 1 companies and a lot of the junior sphere adopting these technologies. Take XRF, so handheld XRF as an example here. I mean, XRF has its roots in research. It's a really well-published technique. It's a really reliable and repeatable technology. But the adoption of XRF has been very slow within our industry. And I think a lot of it's really about changing our mindset to adopt these new techniques and actually use them to our advantage to not only collect more data and have that data as ease of access, have multiple teams looking at that data and freeing up the geologist's time to use the data and take that to do their geological interpretation, but also to actually understand what technology is out there and put it to good use.
Excellent. Yeah, good answers. I mean, I would agree. Just kind of to piggyback off what you guys were saying and Dan too, just actually drawing value out of that data, right? Having it organized and a lot of technologies that can help us get that to a better state now to, use our professions and actually draw the value that's really going to point us towards discovery. I think that's, the perfect marriage of what we're looking for here. And, the different technologies that are coming out can really help us get to that point. And if there's people that can utilize this and kind of prove it, then maybe we're approaching that next step change, as you said, Dan. So that kind of leads us into the next question. So just, you touched a little bit on this, Dan, too, just challenges. You've had a long and fruitful exploration career. So challenges facing exploration. So, as you said, Doug, a lot of the low-hanging fruit has, been snatched up. We're looking deeper, we're looking undercover. This is a good one for you, Richard, too. You're not getting away from this one. But the stuff that Fleet's doing to help us, potentially see deeper with the ANT technology you guys are coming out with, and applying that to some new applications, i.e. uranium exploration in the Athabasca Basin. So I'll pass it over to you guys. Maybe, Dan, you want to start with this one and then pass it off to Richard. But looking at the critical challenges that are facing us as explorationists today, and how can technology help us address those and really pull the value out to help expedite discovery, regardless of commodity.
Okay, thanks. As Doug commented, the industry as a whole, we are faced with declining discovery rates per, say, exploration dollar spent. I'd say the Athabasca Basin is a bit of an anomaly compared to other commodities and regions. Like you think of, there's, say, from 2000 on, there's been a number of notable, in some cases, world-class discoveries made in the basin. But in general, it's a real challenge for the industry. So, to me, there's two aspects of exploration could facilitate exploration success. One is drilling better targets, and again, to me, that's pairing, call it sort of old school geological or ore deposit geological knowledge with innovative technology. And it doesn't mean we should throw out the old technology, right? Like there's stuff like EM surveys have been around, they still serve us very well, but some of the stuff that's coming forward now, like again, the ISO's been using Fleet's seismic system quite extensively and getting good results from it. So that's one thing, is sort of pairing knowledge with new technology to target better. But the other, and we always, I guess as geologists and geophysicists, we tend to think about our exploration technology, but the other is call it the efficiency of the exploration. So how many tests can you do? So you want to do better tests, and that's where your geoscience comes in, but operational efficiency. So if you could drill holes for half the price we drill holes now, and I don't have any magic answers there, but I just throw that out as something to think about, like the developments in drilling technology or operational efficiencies. One of like communications, right? Satellite, love them or hate them, Elon Musk has made our ability to communicate between the field and head office and consultants much, much more efficient. So collaborative discussions. So yeah, I don't have a silver bullet or magic answer, but I'd say the pairing of better geoscience with the operational efficiencies that technology can bring too.
Thanks, Dan. So I think two of the challenges that technology can help with a lot. The first one is just helping to eliminate bias, right? We're all hearing about data science, machine learning, AI. You can't go anywhere without hearing about the monumental change that's going to have, not just on mining, but every single industry. And I think that is one of the challenges of the mining industry. We do all have biases. We have our pet projects. The data doesn't lie. It's emotionless. It doesn't care how much money's been spent on a project or how much effort's been put into it. It just gives you the answers. So I think now that we have this computational ability to process these enormous data sets, when the data is correctly structured, we can get these non-biased, data-driven answers that will help us make better exploration decisions in a way that we couldn't before. And then I think it's not as an interesting answer, but time and time again we hear about the exploration industry has a people challenge. Where are we getting the next generation of geologists and geophysicists and explorers from? And there's not enough students going into earth sciences, going into geology. I think technology can play a big role in that, because you can have the best of both worlds. You can go into the exploration industry and you get to be out traveling the world, being in all these amazing places, but you're also working with cutting edge technology that is just as good at, if not better than, what you're playing with in other industries like finance or other sort of civil engineering. So I think as an industry we can do a much better job in using that technology story to help attract more talent.
I don't want to go down, too far down a rabbit hole, but a bit of kickback. Yeah, so you're talking about technology and the rising cost of exploration, and there's been, I think, a lot of the focus in drilling technology advancement has been just favored towards the oil and gas industry. So we're starting to see that now in the diamond drilling and or the hard rock side, but. So the cost of exploration is something that matters a lot, because every dollar you can save or be more efficient with is maybe another meter, which may be the difference between a discovery or kiboshing a program and walking away from it. We've seen that a lot when somebody else comes in and finds a discovery that you were just 20 meters short of. So utilization of your budget a lot better, and so not so much a technology thing, but I had to give a surprise talk at SEG in Namibia. They told me the night before, and so I had to figure something out for the next day. And learning from Dan in my younger geology a little bit, I was in your quartz textures class and a few things in Cameco, so I learned a little bit. And the amount of professionals after COVID, where is everybody? There's not enough people. So technology doesn't replace people; it just allows the people that are left to be more efficient with their time and being able to use their brain a little more than just the mundane tasks. So I said at SEG there, the geologists or the scientists, they're less and less available. There's a big swing from the old guard and the new guard, and there's amount of data that's sitting in their head, Dennis's and a few other people. That knowledge transfer just is not going to happen overnight or at all in some cases, and that just goes away. So anyway, when you're training your junior geologists, you're not just training the geologists for your company. You're training them because they're going to be training someone. They're not going to work at that company forever. So it's really important to set that standard or that work ethic in the junior geologists that are coming right out of school. And back to data, tell them to collect as much data as they can when they're in the field. No client wants to hear, oh, we took a helicopter to the field and we brought back 15 rock samples. He just looks at it and goes, that was $4,000 a sample. So it's just really important to take some of the senior geologists and geophysicists and scientists and start transferring that knowledge down the way field programs should be run. Not just focused on the shiny technology.
Yeah, I couldn't agree more, Doug. And just to kind of go back to your point there about efficiency and cost, I mean, I see it in my line of work all the time. The time taken from discovery through to production, I think, is a real challenge in our industry. I mean, I looked it up relatively recently, and I think the Canadian Mining Association of Canada says that in Canada alone, the time taken from discovery all the way through feasibility and into production is about 17 years on average. And if you think about the challenges of trying to meet green energy targets, exploration for critical minerals, battery metals, all of these green energy targets that we're trying to meet, and yet that timeline of 17 years, and it's even worse in some other countries, is a real challenge. And I think we need to really shorten that gap from the discovery point in exploration all the way through to production. And I think, and I'm going to focus this now more towards core scanning and core logging, I think automation and non-subjective technology like core scanning can really help bridge that gap. I mean, you see so many juniors kind of, okay, you've made a discovery, and then it's drill, drill, drill. You want to assess your resource. You want to basically drill to target as quickly as possible because you're going through, major sort of investment strategies, and, you want to keep costs down, and you want to get to that stage as quickly as possible. And then you get to feasibility. And at this stage, you might try and sell to a mining company, or, I mean, you see it a lot where companies just seem to fall into this abyss. They're ranking up all of their costs and feasibility through assaying, multiple testing, and then they just seem to fall into this abyss. And what we want to do is find a way, and this could be through modern technology, where we're basically bridging the gap so that we can propel ourselves through feasibility all the way through into production. And we need to find ways of doing that faster and faster so we can actually shorten that gap. And I think a lot of technology, whether it be remote sensing, whether it be automated core scanning, whether it be AI as well, can really help do that and shorten that timeline.
I'm going to add to that, Alice, just for a sec. So, and if everyone blames permitting and government and for everything and the capital markets for the delay and to get to where we want to get to, but there's things we can do as explorationists to speed that process up and not have to go back to the day one and re-log the geotechnical logging for the mining engineers. So if you treated your project like it was at a feasibility stage from day one, there's things we can do to expedite that prolonged process from discovery to production.
Sorry, just one last point. That's a really good point, Doug. And I think it's really important that in exploration we adopt these new techniques early on, because if you let's say you collect core scanning data, so mineralogy data, geochemistry data, high resolution imaging, mag-sus, all of those parameters early on, that can help save a huge amount of costs, whether it be in mine planning later down the line, and it can also shorten that gap. So I think it's really important to adopt these techniques. The earlier, the better.
100% agree. Well said, guys. I mean, that leads kind of nicely into the next section here that I want to get into. Touched on by pretty much every one of you. There is a big theme is collaboration, right? How can we diversify? How can we use, that old school hard knowledge that, I appreciate so much, Dan, being a geoscientist and really cutting the crap and getting down to brass tacks on the ore deposits geology. But how, can these new technologies be integrated, and especially early? Like coming from working on a project like the Arrow deposit at NextGen, when we were like pushing towards feasibility, bringing that knowledge into brand new grassroots exploration projects where it's like, hey, yeah, maybe we should start collecting this data from day one, because then that saves a ton of time. You're not re-logging, there's a lot of benefits to that. And then also with those, even just the physical properties, right? If you're really hoping to drive towards that discovery, those are things you're gonna wanna have to record, right? Is because you wanna build a mine. So here's the question. How can integration between all of these different technologies, Dan, you touched on this a couple different times, but EM is obviously a huge one, so airborne surveys, ground-based surveys, and then drilling technologies, which you also talked about, Doug. That's super important things. So how can we collaborate across different disciplines, not just technology and geoscience, but also engineering and drilling, and how can we collaborate to improve and expedite our exploration outcomes? This is open to anyone who wants to first.
Dan wants it.
Dan wants
He
it.
whispered. He said, "I got this one, Doug.
There
Let
you
me handle it."
Yeah, well, to me, collaboration's key, whether it's within your exploration team or between your exploration team and an outside consultant. So I'm a big fan of, like, when we engage a service provider, do a geophysical survey for us, there's huge value if we have a working relationship, and we do with the people we work with at ISO, versus just a delivery of a product, right? If somebody does a survey for you and drops a stack of maps and a report and some data either into your network or onto your table, the value that's derived from the discussions, the sort of what ifs, and particularly like the relationship between geology and geophysics is very iterative, right? Like Kyle will tell us that geophysical responses they're non-unique. You get a mag high, there's probably like at least a half a dozen things that a mag high could be. So it's a constant, you go out and map, or you drill some holes, and then you can feed back to the geophysicist on, now you've got some truth points or constraints for the geophysics. But the other side of that is, people doing geological interpretations have to honor the geophysical patterns. Like, there's no point in, joining up all your geological contacts trending northeast if your mag is going northwest, right? So it's collaboration between the various subject matter experts and between service providers, consultants, and the company people is critical to me.
Yeah, I agree, Dan. That's one of the, I guess, fundamentals of Axiom is collaboration, just for like one ultimate goal, is this successful project, whatever it may be. So, and you see a lot of like silos or divisions within a company, let alone within an industry, right? So that utopia, I don't know, will ever exist where everybody just gets along and shares everything, but we get close to it as we can. So yeah, the language that each discipline speaks is drastically different from geophysics to geology, but it doesn't have to be. It can be built together, like the processing, post-processing, interpretation. And then, yeah, when you get a service provider or consultant that just, like you say, drops the maps on your desk, or the receiver of that deliverable or product, no, we don't need to hear it. Like, we know what we're doing here. So why not listen? Why not add that advice in there and take every possible thing that somebody knows in their entire career and add it to your interpretation, just for a more comprehensive or a possible result?
I think when I hear the word collaboration, I'm thinking about it from an early technology perspective. And for us, collaboration is hugely important, because ultimately, all the mineral exploration companies, they have a way of doing things. They have a proven recipe, and that's worked for them for years and years and years, right? They're not necessarily getting the same results as they used to get from it, because things are getting more expensive and everything near surface is gone. But they have a formula, a way of doing things, of exploring, that works. And if we're coming to the table with a new technology that is effectively unproven, that is a huge risk for a company to take. And so for us, that collaboration of them, the companies that are willing to take a bit more of a bet, a bit more of a risk on those early technologies, a bit like ISO, it's hugely important in developing that technology, because you can point the companies in the correct direction, and you can give them that feedback that actually hones in that solution and makes it much more applicable to that industry or that certain deposit type. So you are taking that risk, and if it works, you look like a genius. If it doesn't, you've got egg on your face. But if you're early to market and you're willing to give these newer technologies that sort of foot in the door, you actually do get to help shape it and mold it to the benefit of your company. And I think that's been hugely important for us. And but you've got to be able to take that risk. So for me, the collaboration is, are there enough companies that are willing to adjust their approach to make room for new technologies, not replace it altogether, but make room, because some companies have that in their DNA and they're always the first to try everything, and a lot of you know those companies like, well, we'll just wait until they've tried it, we'll see how it works for them. But I think if there were more companies that were willing to sort of collaborate with these early stage tech companies, we could accelerate the technology and the adoption and ultimately get to those predictable, trusted outcomes, which is where everyone's looking to get to.
Thank you. Yeah, and just to go back to our point about collaboration between service providers and exploration juniors, I think that's really important that the service provider has a very continuous relationship as a junior might be using this new tech. So, for example, I see it all the time. A lot of companies will look to adopt new technology and there'll be a plethora of data to work with there. And then they have all of this data, and then data management becomes a real issue. It's almost like information overload. We have all this data, and we now don't know what to do with it. So I think really having a good relationship with your service provider, whether it be remote sensing techniques, whether it be core scanning, whatever the case may be, having that relationship where we can advise you, okay, well, this is how you could use your data. You could take it, you could feed it into your geological models, your geometallurgical models, whatever the case may be. You can use it in some sort of useful way so that you're not just completely overwhelmed with data collection. So I think having that good relationship is really important.
I would 100% agree. I know the Axiom people, not too bad. It's pretty good. And no, I totally echo that. I think it's super critical to, really accomplishing what we're trying to accomplish here and succeeding together. So that leads perfectly into the next question. So thanks for setting me up and making my job easier. So the role that collaboration plays in really driving new innovation in technology. So, identifying a problem. So, Dan and I are out here trying to find uranium deposits, and we're like, hey, what else can we throw at this thing to try and find these things quicker, or find the deeper ones or the harder ones to find. So I think Richard, Gibbo, you're gonna fire this one off, buddy. But with what Fleet Space is doing, and like you said, speaking to companies willing to take that risk, willing to kind of jump off that cliff with you, and it's been interesting to see Fleet Space come into the Athabasca Basin. Clearly, you guys, DB is, we've talked a lot about this and proving that technology for other types of mineral deposits around the globe. But coming into the basin's a big leap, So, and we have a way of doing things. So it's been really interesting to kind of watch that journey over the last couple of years of you guys coming in. Pardon me. And so I'm going to put this one to you. How, and Dan can probably piggyback off this as well, you guys working with ISO and the hurricane area there in Laroque, how does that really help, and what new innovations, how has it helped you guys really drive your product? And like you mentioned, you have some new AI drill targeting methods, you're integrating other things just, along with the ANT technology. So speak to the partnership and how that helps really drive things forward.
I mean, Dan would probably be much better to speak about this one, but I think what we are trying to do is speed everything up, right? So we can make decisions about exploration as quickly as possible. And what we're enabling with the sort of real-time data transfer is you can go out and you can collect this geophysical data set. You can then process it into a physical property 3D model. You can then interpret that, and then you can go and test those interpretations with drilling, and that can all be done in the same season, as opposed to having to, assess the data and then potentially drill it the next season. But the more that we work with companies like ISO, we're learning that our technology can be pushed in different directions that we didn't necessarily understand. So if you go 4 years ago, we didn't know anything about mineral exploration. We were just building satellites. So it's been a very steep learning curve for us as we've added more mining expertise to our team. But I think when we first started doing this, we thought it would mainly have purely sort of brownfield type applications, and now we have customers that are pushing us into greenfield applications, and the other way into geotechnical stuff for end of mine life. So you really, particularly when you don't have a lot of that industry expertise as a technology company, you're really relying on people like Dan to guide you and say, hey, this is how it should work, this is how we think it should be applied, and this is what we'd like it to do. And then it just becomes a conversation as to how do you get to that end point. But rather than me blabbering on, I might just hear from Dan himself.
No, I'd certainly echo that. Obviously from press releases we've issued, we're very bullish on Fleet Space's ANT or seismic technology. But beyond the technology itself, there's a couple of things. One is the speed of being able to test targets, and a couple of people have already commented on that. So traditionally, you would maybe do a geophysical or a geochemical survey one field season, and it might be the next field season, or maybe a whole different year if it's only, say, winter accessible terrain before you could get in and drill. So with the satellite connectivity, both from the aspect of their geodes being able to transmit data by satellite, so their people and ours can view it essentially the day after it's generated. And then you also have the communications technology that, we've got satellite comms, we've got software like, Zoom or Team or whatever that we can talk to each other from between Australia and Canada. So there's this whole chain of thing, the instrumentation's easier to deploy. You've got satellite comms that can send the data out as opposed to, sending it out on a float plane a few decades ago every couple of weeks or whatever. And then you've got communications technology and software like Teams that allows people to collaborate. And then you've got the humans that, as Doug talked about, the challenge of actually getting humans to collaborate out of their silo. And I can say we feel a very productive relationship with Fleet. So it's all that whole chain of technological innovations and human technology and human interactions that are making us better, right? It's not just one single aspect.
I think like any innovation or technology, the last step is always optimization. So that's so we have Axiom has some of our own IP, but mostly it's utilizing other people's technology. And then the optimization part comes in when you have a good collaboration. So it's expensive to explore in remote areas of Saskatchewan or elsewhere. So, well, what's one of the biggest costs? Getting there and doing the work, not the actual data collection itself. So what more can you collect while you're in the field? So I know, the Fleet's ANT and the near real time. All right, so if you're out there and you're also collecting, gravity stations at the same time you're collecting Fleet velocity models or ANT, well, maybe that's not a tight enough grid for the gravity. So, but if you're able to quickly look at the anomalies, the seismic anomalies, well, then when you got to go back and pick up the nodes. Well, now you have a new focus area to maybe, while you're collecting those nodes, be collecting a tighter gravity grid. Or why don't we just throw, a radon probe in there at the same time, and just keep adding things to reduce the overall cost and collecting more data. But it only comes through when industry service providers are talking and collaborating, where you can all add your own knowledge in there, your own specialty to, reduce the costs.
Yeah, I couldn't agree more, Doug. I think whatever we can do, whether it be new technology, new techniques, new methodology, whatever we can do on site to help speed up the process, collect data in near real time, as we've said, whatever we can do there, we can use to optimize our drill programs and hopefully not waste our time on further drilling, moving away from the target, but use the near real-time data to actually drill towards target and just optimize those drill programs. And it kind of goes back to the point I was getting to earlier on. The better we can use technology early on, the better we can start our optimizations and hopefully have cost savings in the long run.
Just want to add one thing. We talk about collaboration and speeding the process up. But we forget one of the biggest and most important collaborations is the First Nations communities on the areas we're exploring. You want to speed something up, you want to be more efficient at what you do. You don't have to follow the guidelines that the government puts out for you. Everybody here knows how to talk. Everyone here knows how to engage certain people. That should be done way earlier than we're doing it. It's not something to be feared because you're leaving one of the biggest components to the end of your whole cycle, and it should be done first, not last. So that's just collaboration. I missed that one.
Yep, that's an extremely important one. It's not a barrier or a burden. It's an opportunity.
Yep.
That's how I've always looked at it. So well said, Doug. Okay, let's look at some forward-looking topics here. Let's have a little bit of fun. So first thing, just quickly, we'll get through this since we're a little bit behind time. Tell me, out of the emerging technologies that are coming up, it could be your own, either through geotech or through fleet or different things, but everybody gets to give me one answer on this. What is your, what are you most excited about? What sort of technology or something specific are you most excited about and its application in mineral exploration? Alice?
Well, I think something we've only kind of half touched upon here is AI and machine learning. I mean, we see it more and more. It's, pretty public now. The ChatGPT coming towards the public a couple of years ago. We're starting to, I can see it in my everyday, we're starting to almost rely on AI. So I think it's a really important topic to discuss because I think although AI can do wonders, I think it's something that we have to be quite cautious about relying on. I mean, everything we've touched upon today, none of this takes away from the geologist. You can still use new technology, but the geologist is always going to be required. I think what AI can do is help us tackle some challenges. So for example, we touched upon data management. So I would hope that AI can start to help us optimize data management, start to interpret the data. I mean, we have so many different types of data sets that we've discussed today, remote, core scanning, even assaying. You'd hope that AI can kind of bring that all together and help the geologists with our geological understanding of the deposit. That's definitely something I'm very excited for over the next decade. I think we'll see more and more of it.
Sorry to repeat, Alice, but for me it's AI as well. AI is literally going to change the planet as we know it over the next, I'd say, 3 to 5 years. You're either really bullish on it and you believe that, or you're not. It's a bit like crypto, you believe it or you don't. But AI has arrived, it is coming, and it's going to change literally how everything works. And I don't think we can predict all of the outcomes and how that will apply to particular industries yet, but I would say if you're not utilizing AI in some way, shape or form, even just to automate tedious processes that don't need to be done so that you can focus on more interesting work. Educate yourself. Everyone, we're a service provider and every single service provider is now saying, oh, we use AI, we have AI. And there's many different forms as to what that means and what that takes. So as a business, it's important to educate yourself on what it all actually means and what does that mean for my industry and what does that mean in practical terms. If you are interested in what we're doing with AI, I'd encourage you to come check out our booth at Open House for a more detailed conversation.
Well, I can't say AI now. It's been used, so I'll say not particularly one technology, but the advancements of different sensors, like what Fleet's doing, Diaz's QMag, like things like that are being able to look at things in more detail, deeper, more accuracy. So the advancements of sensors, and I'll leave it at that. AI.
I guess I have to be the one grouchy old guy on the panel. We're excited. We've embarked on an AI project with Fleet on our Larock project where the hurricane deposit's hosted. And for me, the jury's still out. I'm excited to see what the results will be. I'm of the, the sort of subject matter, old school way of approaching things. So, yeah, it'll be an interesting venture. I guess my one piece of excitement, or biggest piece of excitement, would be getting back to maybe some of Doug's early comments about data. And I had this, I was part of a committee that designed the CIMIC Footprints project several years ago, a large national exploration research project. And when we were asked to vision, what would think some of the big steps forward in exploration would be, and I get back to this idea of, at our heart as explorationists, we should be geologists or geophysicists. We use the technology to be better at what we do, but the technology itself is not the end goal. And so the comment I threw out was, maybe watch too many of those cheap police shows, but when you watch CSI or whatever, and they've got the big monitor and they're just throwing up crime, they're just grabbing with their hand and swiping and throwing up crime scene photos and old driver's records from 1953 or whatever. That's my vision for a really cool exploration discussion, right? As a group of geochemists, mineralogists, geophysicists, geologists, whatever, in a room, and we want to see Kyle's 3D EM inversion, so we just swipe it up onto the screen and there's a 3D model, right? It's making the software almost transparent. So it's the data is organized, the software is transparent. Even an old guy like me could flip a 3D model up and migrate around in it. That would allow us to do what as explorationists brings the greatest value, is be geologists, be geophysicists, not software operators.
It's still like an overhead projector, projecting it onto a whiteboard, and then have 10 people draw different trends and lines, and then shut it off, and you see the patterns. So, yeah.
I totally agree, Dan. That would be badass. Really getting your face in the rocks, but it just in a 3D sense instead of a screen. That would be awesome. Yeah. Okay. You guys are just giving me all the perfect segues here. So let's wrap things up here just with kind of a final question before any final comments or questions. Back to the data management thing and optimization. That's a big word here. Is you can do all these things. You can throw the book at a project, but the main thing is having clean data and being able to really draw value out of that. I think we can do our jobs best as geophysicists and geoscientists if and optimize our roles by looking at well-organized and, well QA/QC data. So obviously that's, basically where we started this conversation, was data being the most valuable asset in exploration, essentially, or one of those at least. But a lot of companies do struggle with organization, integrity of that data, accessibility of that data. So how can us as companies, or, Fleet or Geotech as vendors kind of thing, helping us out, how can we optimize our data to ensure that we are AI ready, since it's everyone's favorite, and why is that critical to our exploration success?
Thanks, Sean. Well, I think a lot of it is really in finding some sort of standardized approach. So, we're seeing new technology being adopted more and more. As long as the industry keeps adopting these new techniques, if we come up with some sort of standardization, some sort of consistent data set we can go back to, we can make sure that as an industry we're using that to create this sort of AI-ready data set, so that we can use it to further inform our geological interpretation. So I think a lot of it is about standardization within the industry and consistency, and going from there, really.
And I think ultimately it just means a lot of boring sort of clean-up work before you get to the exciting stuff. And whether that's digitizing some of your legacy assets, or just making sure, as Alice said, that everything is standardized, that is all work that needs to be done before you can take advantage of these sort of machine learning capabilities that these technologies have to offer. Ultimately, these decisions, that the outputs that are coming from these programs, are purely data driven. So if you put crap in, you're going to get crap out. And so it's really important that you are utilizing and building from a solid frame. It's a bit like when you're painting your house a fun color. It's boring putting the primer on first, but you've got to do it if you want to get the correct result.
Yeah, and I think the only way to do that and then actually maintain that during busy times is somebody has to be like accountable in your organization for the maintenance. Everyone's cleaned their garage, and then next like spring it's a nightmare again. Why? Because like there's not one person. There's a lot of people in your garage, and they don't put things back in the right place. So somebody has to be given the time and the budget to be able, and accountability to be able to maintain that database, to continue to use it, and then also give them the leeway to, or the direction to clean something up. I was learning a fancy word on the way over here, and I have to use it. And so it's like so looking at all historical data and everything. If you have a epistemological approach. I don't know how to spell that. It's just like, I cannot spell that. No, I don't think anybody can. So, but it's just like it's the difference between a justified decision or like an opinion. So like knowing the source, like the origin of the data, the limitations and the scope of the data, and if you have that, fully understood and confident across your organization, and then build on that. But somebody has to be appointed that keeper, and somebody has to maintain that, and otherwise it just gets out of hand. The amounts of data that are coming in off these technologies is insane. Like it's a lot. We've done like a few years ago, 5-6 years ago, like 600 square kilometers of lidar data for an operating mine, and they don't even have the ability to receive the data. Like they're like, our computers can't handle this. So even the people asking for the data, they can't even receive it, let alone manage it. So it's just really important to understand.
Yeah, I'd agree. A couple points Doug raised, and we at ISO are trying to do. We've got a GIS manager, Lisa, that lives out in Gander, Newfoundland, and again, there's technology, right? We're able to collaborate with her remotely because of the communications technology. But so she's accountable for the organization and quality of our geoscience data. But on the front end, the other thing is to make the field teams aware of, it's the principle, the sort of measure twice, cut once, right? Like how much rework has to be done if incomplete or bad data goes into the database. We've all done compilations or whatever where you spend more time collecting and organizing your data and cleaning it than you do actually doing your 3D model or GIS product or whatever. So a standardized data format that can feed different platforms. So if the end user wants to use QGIS versus ARC versus Micromine or Leapfrog, that data can be utilized in multiple platforms. Some accountability, somebody that's got oversight to make sure that, as Doug said, your garage is clean. And then the field teams that are acquiring the data, understanding how valuable their work is and how costly, say, mistakes or incomplete data is. Those will all be components for me.
The database manager has to understand the data as well, the librarian or custodian. So, the most powerful AI is like if it's used for geoscience, if it's built by a geoscientist, like Leapfrog was built, by geologists. So, it's really important.
And I will just say quickly, for companies that are just starting to dip their toe in on this, you don't have to go out and invent the wheel. Geoscience organisations like USGS and Geoscience Australia, they are building sort of best practice frameworks that you can sort of structure your own data management practices on.
And I think just to wrap up there, I think that is a perfect example of AI creating new jobs. There's this scarcity, not just in our industry, but in many different industries, of AI taking away jobs. And this is just one example of AI creating a job, someone to essentially look over the AI component.
Yeah, the scientists need to babysit the robots, for sure. Cool, thank you guys so much. That was, I told you it'd be riveting. That was pretty good, right? Round of applause for the panelists. Look at that, right on time, Julie. Good for us. Okay, again, big thanks to Axiom Group on behalf of Standard Uranium, ISO, Fleet, and Geotech. Thanks very much for having us. It was a good time, great way to kick off Open House, and looking forward to connecting with all of you. And yeah, pleasure to be here. I'm going to pass it over now to Mr. Jordan Freak. There he is. Come on up, buddy. From HeliSource.
All right, hi everyone. My name is Jordan Freak. I represent a group of companies. So our main company is HeliSource, but we actually have a group of aviation companies. So I'll kind of just run through them quickly, who we are, what we do, and then Doug kind of told me that I was up here to do a technology showcase here. The technology I'll show you today is an older technology, but we've kind of taken it from a different industry and kind of implemented it here. So first I'll start with HeliSource. HeliSource is a mid-sized helicopter company. We're 24 helicopters right now. We have a diverse fleet of Jet Rangers, MD-500s, and A-Stars. So we value partnerships in that sense. We've been working with groups like Axiom and Fleet and providing helicopter support for their different projects across northern Saskatchewan over the last number of years. Our next company is called ISS, Integrated Sensing and Surveillance, so it's a fixed-wing company. There's a little more technology in that company. We can provide LiDAR, thermal imaging, gas leak detection on that side. And then our third company is called Tucana Aviation Services. So Tucana can provide airport services, fueling, fuel trucks, things like that. Tucana currently runs the Red Deer Airport and the FBO service. So we kind of have a collaboration of companies that can support everything aviation. So the item I'm here to talk about today is called the Big Runner system. This system has been used in the oil and gas industry for the past, I'm going to say 30 years, kind of implemented in the mid-1990s. So the system is very robust. There's over 5 to 6 million different pics that have been used with this system. I was going to bring it over here today. We do have one for display over at our booth. As you can kind of see on the video I'm going to show, it's like 125 pounds. It's a little bit bulky. I'm happy I didn't try. The elevator was kind of a nightmare to try to get it up there. So, so yeah, we'll show you a video here on how we use this and what we use this for. But I'll quickly speak to the efficiencies, I guess, of this and how we used it last year. So we used it on the fleet program with Axiom, and I kind of want you to picture 20, 30, 50, 100 nodes out in the field, and laying those nodes out can be relatively simple. You're kind of putting people out, you're using a carousel, you're using different bags, and they're walking around northern Saskatchewan and doing different projects with these. But where the Big Runner system comes in handy is when you have to pick up these items. So in traditional, I guess you would say, you'd have to have someone hooking up that load on the bottom of the machine. And so that machine's gonna have to be moving around with people, but people on the ground can only move so quick, especially as you'll see in the video in the dense bush, and I feel like most of you here know better than me, this northern bush of the basin there. So where this system comes in is you're able to set a cone, and the cone has a rod in it, and the pilot comes in and it puts that right side, there's kind of like that red portion there, and it kind of implements that on there, and then it grabs a magnetic and is able to pick the bag. So if you want to display the video, I can just walk us through it. So I apologize for some of the video quality. Most of this is taken with like phones in the field.
Yeah, and I want to play video.
The system is good up to 2,500 pounds, and you're able to pick 4 to 5 different bags with it. So on this, it's a little bit hard to see. You can notice the dense bugs.
It's nothing.
Yeah, this was a program from this summer. We're utilizing a helicopter called the MD-500 here. The 500's been used for traditional seismic for decades, and it seems to be the best aircraft for this. So the aircraft has 4 bags on there, I believe, 3 bags already, and this cone has been set already by the Axiom team in the field. So as we come in, there is no need for anyone to be on the ground. They stayed back to get this one video. So that cone set, the bag's next to it, the fleet gear is inside the bag. Pilot sets it down next to it, and then you're going to see him from 130-foot long line, so it does take some precision and some practice. Laid on that cone, it locks into place, and then you're able to fly away with that. We understand helicopters are expensive, and that your projects have budgets. We are there to partner with different companies in making your guys' projects more efficient, choosing the right helicopter for your project, and how do we stay within that budget of your project too. So, like I said at kind of the start, HeliSource is really valued on partnerships, and then what we can do to make those projects better. So he's just kind of getting it off the ground here, and then slowly fly back to staging. So we've been working with Fleet and Axiom in taking our knowledge from the oil and gas sector and implement it into the mineral exploration sector here, and how the efficiencies, that seems to be a really key word today, is efficiencies, and how we can make these projects go quicker. As everyone here kind of knows, if you can cut 3, 4 a week off, 3, 4, 5 days off your project, that is a massive, massive efficiency. The quicker you can kind of get in there and safely do everything while collecting all the data that Doug spoke about earlier, the better. So here's another example of the machine in northern Saskatchewan there, picking up a bag and going all the way through. In the traditional seismic days, we used to do hundreds of these a day. Within the fleet aspect, we're doing, depends on what process we're at with that survey. But again, the efficiencies of being able to set a GPS location, and then the pilot has that information and he's able to go up and pick up all the bags at one time, instead of always setting them over and hovering in one bag at a time, one bag, one set, one net, is going to drastically cut down on your helicopter time, but it's also going to improve safety. So now you have less people in the field, you have less people up below the line of the helicopter, which can be a risk, and then you have to train people on that side too. So there's many benefits to this system.
Or this is for sensor deployment or sensor pickup. But as a geologist, when I first saw this, I was like, man, you know how many like 200-pound backpacks of soil samples I carried for kilometers? You could collect way more, drop it in that one bag, give them a GPS point, and get back to geology, not like Sherpaing.
That's exactly it. So here we call these pumpkins. They're big bags. We have a bag over there. Anything can be put into those bags. We have 10,000 of those bags in a storage yard somewhere. We have multiple of these bag runner systems, so we have lots of gear. This is a D500 landing. If you're not familiar with the machine, it's not a super popular machine, but that's a machine that you have a really precise handle to kind of do the system. It can also be used with an A-Star. The reason we use the 500 is the cost efficiencies, but again, we look at program to program. Not every program is going to be the exact same one. Even if you're 50 kilometers away, it all depends on your road access, your staging, where we can put mobile charging. There's so many different aspects in this. So over the last 6 months, we've had numerous conversations with Fleet and Axiom, and just efficiencies on this and how we can be better. I think we did a really good job last year, but the goal moving forward is to utilize the aircraft in the best way we can, and help kind of get that data for the companies. That's the most important part here, so we're just trying to play our role in that. So does anyone have any questions on the system? Perfect.
Looks good.
Thanks, guys.
Absolutely. Thanks, Jordan. That's really cool, man. A lot of applications that would make people's lives easier, so that's fantastic. So thanks again for joining us. It was riveting, and thanks to the panelists for some good stuff. Make sure you chat up Alice about Geotech's cool work with the box scan and other technologies, as well as Gibbo and DB and Steve here from Fleet Space. And yeah, I'll be around as well. Say
Leave
hello.
Dan and Doug alone.
That's all I got for you.
Thanks, Sean.